Hello and welcome to Math IPREP Part 2. My name is Matthew and I will be instructing for today. So in Part 2, we're going to cover order of operations, solving for one unknown, solving for two unknowns, factoring, polynomials and quadratics, and the quadratic equation and formula. So let's get started. So first, we'll talk about the order of operations. So the way we remember this is PEMDAS. We have parentheses and exponents, multiplication and division, addition and subtraction. So an important thing to note about PEMDAS is that these steps happen at the same time as do these steps. So you could write PEMDAS as P, E, D, M, S, A. And that would be correct because multiplication and division happen at the same time and addition and subtraction happen at the same time, just left to right. So let's go ahead and look at an example to see how this works. So when we're solving, we start with parentheses, which means we'll solve this before any other part of the equation. Next up, we look at exponents, which we have 2 to the third. So 2 to the third power is 2 times 2 times 2, which comes out to 8, plus 3 equals 11. And then we can continue to solve from here. So 5 plus 3 times 11. So from here, what would be our next step? Multiplication and division, right? So we see we have one multiplication, 3 times 11, so 33. 5 plus 33. And we look at addition and subtraction as our last step, so we'll add these together and we get an answer of 38. All right, let's move on to the next slide. So solving for an unknown. When solving for an unknown, you are, quote, undoing the algebra that already exists. So you're working backwards through the order of operations. So instead of parentheses, exponents, multiplication, division, addition, subtraction, you're going to go the other way. So you're going to start with addition and subtraction, and then you'll move into multiplication, division, and then finally you'll work on your exponents. So sometimes there are multiple unknowns, and we're going to see an example of this in a minute that will help solve together. But here are just some examples you can look at. So 5x plus 3y equals 2. You see there are two unknowns in that equation, whereas in this one, 4x equals 4. There's just the one unknown x. So when we're solving for a single unknown, our goal is to get the unknown on one side of the equation all by itself. So then, because then it will read something like x equals something, right? But whatever that something is, that is the value of x. So the way we do this is we complete addition and subtraction, and then multiplication, division, and then we work inside of parentheses to remove radicals and exponents. So let's go ahead and see what this looks like. So in this example, we have 4x plus 2 is equal to 4. So the first thing we would do is our addition and subtraction. So we have this plus 2, and we're trying to get it away from this x. So how we do that is we subtract it. So if we have 4x plus 2, we subtract that 2, right? So it's no longer on the left side. But it's important to note, whatever you do to the left, you must also do to the right. So we have minus 2 here. So over here, we also have to have minus 2. And what that will look like is 4x is equal to 2. And then our next step, multiplication, division, we're going to divide. So we have 4x. To get this x all by itself, we have to get rid of this 4. And so if it's 4 times x, we're going to do 4x divided by 4. And if we simplify, we have x equals 1/2. All right. So here are some more examples that we can work through together. So first, we have 4x equals 4. So think about PEMDAS. Think, how would you work through this equation? Now remember, when we solve, we work backwards. So you'll start here, and then here. So we have 4x equals 4. Is there any addition or subtraction? No. So next we look at multiplication division. Is there any of that? And in this case, we do have multiplication, 4 times x. So we're going to divide that 4, and we're left with x is equal to 1. Awesome. So let's go ahead and move on to the next one. So here, do we have any addition or subtraction? Yes, right? We have it right here. So we get rid of that, we do minus. So if we have plus, we do the opposite, minus. So we have 4 over 2 equals 4. And then when we simplify this, we write it out, 2x equals 4 minus 4/2. So cool. Next, we're going to work on our multiplication, right? So let's go ahead, and we have 2x. Let's divide this by 2. We'll divide all of this by 2. So you see that we have x is equal to 4. Oh, no, I'm sorry, 2. 2 minus 2 over 2. And remember, if you guys need a refresher on dividing fractions, we have, right, 4/2 divided by 2 over 1. And we switch that to same, switch, flip. We're left with 4 over 4, which is equal to 1. So we can write that down here. It's 2 minus 1. So then x is equal to 1. Right, because 2 minus 1 equals 1. So in both of these examples, x is equal to 1. It's just a very different way of how we get there. So now let's talk about solving for 2 unknowns. We have how to solve for x, but what if we have an equation with x and y? So when you have 2 unknowns, you can solve for both, but you can only do this if you're given 2 equations. And you'll see what that looks like in just 1 second. So the method for solving is very similar to how you solve for 1 unknown. Each equation is like a puzzle piece, and you must use both to complete the puzzle. So here is the steps. So our goal is to get 1 unknown variable alone and then substitute it into the other equation. So go ahead and write down all these steps, and we'll go through them together right now, and then also again in a minute when we look at our example. So step 1, solve for the first variable by doing addition and subtraction, multiplication and division, and then work inside the parentheses to remove radicals and exponents. And this is the same step for solving for 1 unknown. So now this is where it gets a little bit different. So we have to treat this other variable as a number. So we substitute that into the second equation, and then we solve for the second variable, and then we substitute the answer for the second variable into our original equation for the first variable. And I know this can sound really confusing, especially, because we're not really looking at an equation, but let's go ahead and see what this looks like. So we have 2 equations here, right? We have y minus x is equal to -1, and we have 2x minus 3y is equal to -1. So the first thing we do is we want to take one of our equations, and we want to get one of the variables all alone, right? So in this case, we're deciding to solve for y. In this first equation, y minus x equals -1. We add x, we end up with y equals x minus 1. Our next step is to substitute that into our second equation. And here's what that looks like. So if we have 2x minus 3y, right? So now we take this y and we substitute in x minus 1 because we know that y equals x minus 1. So this y turns into 3x minus 1. And then you just solve for x just how you would normally. So you distribute this 3, so it becomes 2x minus 3x plus 3. And then you just simplify. And what your answer is x minus 4. But we're not done yet, right? Because as we know, we still have to solve for y. So all you do here is you plug in your answer for x into either equation, whichever one is easier. So in this case, our first one looks pretty easy, right? Y minus x equals -1. So we'll go ahead and plug it in. So y minus x, or y equals x minus 1, becomes y equals 4 minus 1, right? And then when we solve for that, we get y equals 3. So as you can see, we can get both of our variables just by following the steps we had on the last page. And if you need to go back and look, I would definitely do that and write those down in your notebook because they are very helpful and very important to know. So there's our answers, right? X equals 4, y equals 3. And sometimes when you see two equations together like this, some of your professors or the students might refer to this as a system. And that's just because these two equations are connected. They're not isolated, they work together. All right, so here are some helpful hints when you're solving for two variables. Hint number 1, solve for whatever variable is easiest to isolate first. So really, whatever looks the easiest is probably going to be the easiest. So just try to find one variable that's easy and solve for that first. When you're plugging in at the end, use the easiest equation. So again, when you're checking your answers, right, you have your x, you're still looking for your y. So let's say x equals 3 and y equals blank. When you plug in this 3, make sure you put it into the easy equation, right? So on our last slide, it was y minus x equals -1, right? The third hint is check your work using both equations when you're done. So after you finish and you get your x and your y values, plug those in. Make sure those answers line up, right? Because if you plug in x and y and your answers don't line up on either side of the equal sign, then you know you made a mistake somewhere and you have to go look for that. The fourth hint is make sure to write your answer clearly when done. So don't stop at just putting all your math. Make sure you put x equals whatever and y equals whatever. And a lot of times what this can look like is this. We have x, comma, y, right? So you put your x value and your y value, or you can do x equals, y equals. So either of those are correct. And it just really depends on the teacher, the professor, and what they're asking for and what you're trying to solve. All right, so let's go ahead and try this. So we have two equations. We have y equals -2, and we have 4x minus 3y equals 18. So the first thing to note here is that we have our value for y. Y is equal to -2. So we'll go ahead and put that over here. Y equals -2. Or if we have our x, y answer, we know our y is -2. Right? Remember, this is x, y. Let's go ahead and solve. So we already have isolated one variable, so the first step of the problem is done. So now we can move on to our second step, which is we substitute this into our other equation, right? So let's go ahead and write this down. So what we get, so we get 4x minus 3 -2 is equal to 18. We can simplify that, so it says 4x minus -6 equal to 18. We know that if we have two negatives next to each other, that makes a positive. So now we can go 4x plus 6 is equal to 18. Now we work through PEMDAS backwards, right? So we see if there's any addition or subtraction, and there is. So we have plus 6, so we'd flip that to minus 6, minus 6. So we get 4x is equal to 12. And then after that, we divide, right? So we have 4x, so we have to divide by 4. 12 divided by 4, x is equal to 3. So we could write that over here, x is equal to 3. Or if we're putting it in xy form, it's going to be 3, negative 2. So here's one answer, and here is another. And both of those are acceptable depending on the format. So let's go ahead and try one more together, and then we'll move on to a new topic. So this one we have negative 7x minus 2y equals negative 13. And on this side, we have x minus 2y is equal to 11. So first, you want to choose one of these equations and isolate a variable. So you got to get that variable all by itself. So just looking at these, which of these equations looks simpler and a little bit easier to deal with? Cool. So I would say probably this one, the blue one, right? Because these there's a 7, a 2, a 13, everything is negative. Whereas on this side, the x doesn't really have anything before it, and there's not another negative to deal with over here. So let's go ahead and look at x minus 2y equals 11. Okay, so now we can solve for x. So we have negative 2y. Let's do plus 2y. Plus 2y. So we have x is equal to 2y plus 11. So this is our x right now. That's what we can work with. So now let's go ahead and plug this into our other equation. So we have negative 7, 2y plus 11 minus 2y is equal to negative 13. All right, and now we just have to solve through our PEMDAS, right? So before we do that, we can go ahead and multiply here and distribute this out, and it'll just make it easier. So we do negative 7 times 2, negative 7 times 11, right? So what that looks like is negative 14y minus 7 times 11, which is 77, minus 2y is equal to negative 13. Okay, so now we can do a little bit of simplification, and we can combine like terms, right? So first we can take this, we can do plus 77, and over here, same thing, plus 77, and we can combine this term with this term, right? Because they're both y. So negative 14y minus 2y is going to be negative 16y. And that's going to equal negative 13 plus 77, which is 64. And then we just have to divide this, right? We have to isolate that y. Make sure you keep those negative signs this whole time. Then you finally get an answer of y is equal to negative 4. All right, and then here's the second part, right? Because we have our y, but we still don't have our x value. So let's go back and solve for x. So when we go back, we know y equals negative 4. We can just plug that right back into here. So we'll have x minus 2, negative 4 is equal to 11. Let's go ahead and distribute this. So we have x minus negative 8 equals 11. We talked about earlier, if we have two negatives next to each other here, like minus negative something, we can just turn that into a positive. So x plus 8 equals 11. Subtract 8. we get x, oh, that's too big. X is equal to 3. So we have y equals -4, x equals 3. And if we want to put those together, we can put 3, -4. All right, so that is the end of solving for two variables. So we're going to move into part 2 of part 2, or section 2 of part 2, and we'll discuss factoring polynomials and quadratics, as well as the quadratic equation. So this is part 2 of part 2. So of course, let's go over factoring. So factoring is a process of splitting apart a number or an expression into smaller parts. These parts, also known as factors, can be multiplied back together to equal the original number or expression. So one way we can do this, and to keep track of it visually, is a factor tree. So in a factor tree, each branch is a division, and the ends of each branch are prime numbers. And remember, a prime number is a number that can only divisible by itself and 1. So some examples are 1, 2, 3, 5, 7. And some examples of numbers that are not prime are 4, 6, 8, 9, 10, etc. So let's look at an example of a factor tree. Find the factors of 130. So what we'll do here is we have 130 is equal to 2 times 65. And as we talked about earlier, right, 2 is a prime number, so we stop there. 65 is 5 times 13, and that's a prime number as well. So we can finish there as well. So then we can figure out the factors are these numbers, right? So 2, 5, and 13. But then also we can kind of combine these factors together, right? So we see 2, 5, 13 here, 2, 5, 13. Then if we multiply these together, right? So we have 65 times 2, for example. And 65 is 5 times 13. But then we also have 2 times 5, which comes here. And then we also have 2 times 13, which is here. So as you can see, we can get all of our factors from this tree, and then we can write all of those down. So past factoring, kind of a more complex thing that we factor a lot of the time, besides just a number, is a polynomial. So when you're factoring numbers and polynomials, the process is going to be very similar. For all factoring, you're trying to find numbers and expressions that equal the original when you multiply them back together. Right? So on our last example, if you multiply together, these correct numbers, 130 and 1, you get 130. 2 times 65, 26 times 5, and 10 times 13. So it's the same with a polynomial. You're factoring out this polynomial, and you're just trying to figure out what can multiply back together to figure it out. So for example, the expression 4x squared plus 4x equals 0 can be factored to 4x times x plus 1 is equal to 0. So a hint here is when you factor out, whatever you factor out must be in every term of the polynomial. So here we factored out 4x, and you can see there's a 4x here and a 4x here. So that's where we got that from. So let's go ahead and move on to the next slide. So factoring a quadratic. A quadratic equation is a special type of polynomial which can be written in the standard form ax squared plus bx plus c is equal to 0. Sometimes these can be factored into the form x plus or minus a number times x plus or minus a different number. And that's what this is right here, is plus or minus. So to find these numbers, you simply multiply, you see what multiplies to get value c and what adds to get coefficient b. And when we talk about values and coefficients, we mean these right here, a, b, and c. So let's go ahead and factor the following expression. We have x squared plus 8x plus 12 is equal to 0. 12 has factors of 1, 2, 3, 4, 6, and 12. So when you find all these factors, and the reason we went over factoring is because it makes this a lot easier, right? You're not just guessing like what numbers could possibly add up to, B and multiply to C. You have C, so we know it has a multiply here. So it's either 1 and 12, 2 and 6, or 3 and 4. So which of those add up to 8? 6 and 2. So then we get this answer down here. We get x plus 6 and x plus 2. So let's go ahead and try a couple examples together. So first we have 8x squared plus 2x is equal to 0. So you want to go through this expression and see what you can pull out of each term. So you have one term here and one term here. So when you're thinking about what comes out, right, we have an x, we have a 2, and is 2 a factor of 8? Yes, so we can take out 2x. So we have 2x, and then whatever is left in here. So what's 8x squared divided by 2x? 4x. 2x divided by 2x is equal to 1. And that is our final answer. 2x times 4x plus 1 is equal to 0. So then we can look at a different one, right? And this is going to follow more what we were talking about with our A, B, and C. So we have A, B, and C. So our A here is a 1. If there's ever not a value next to your first x squared, the value is an implied 1 because anything times 1 is itself. So then we find out what multiplies to this number, but adds to this number. So let's look at all our factors of negative 15. So we have 1, we have 15, we have 3, and 5. The important thing here is that we're dealing with a negative number, right? So we have to make sure we're careful. So we have 1 and negative 15, negative 1 and 15. We have 3 and negative 5. And we have negative 3 and positive 5. So which of these, we know that they all multiply to negative 15. So this part is checked. But now which ones add to negative 2? 1 plus negative 15 is negative 14. Negative 1 plus 15 is positive 14. 3 plus negative 5 is going to be negative 2. And negative 3 plus 5 is going to be 2. So which of these are correct? This one, right? So we're going to have x plus 3, x minus 5 equals 0. So as you can see, there are a couple different ways we can factor expressions, either by completely taking them apart, or we can look at our multiplication and division and what factors come out of each one. So here it was 2x. Down here, we got to actually take it apart into two different expressions. Let's go ahead and move on to the next slide. So factoring is actually a first step for solving, right? So we have our factors. So we have x squared minus 2x minus 15 equals 0. We can factor that into x minus 5 and x plus 3 equals 0. And then each factor can be solved for individually. So when we look at this, right, x minus 5, x plus 3 equals 0. What this is saying that for whatever x is, so if we're looking for x equals, it has to end up equaling 0 at the end, right? So the way that this method particularly works is we can just isolate each one because we have two, right? We have a and b, let's say. So if a is equal to x minus 5 and b is equal to x plus 3, we can solve for either one of these because anything times 0 is 0. So if we get either one, a or b to 0, the whole expression equals 0. So then we can go ahead and look through this, right? Cool. So note that not all quadratic formulas can be solved by factoring. And if you can't factor, then you can use a quadratic formula, which we'll go over in just a second. So the quadratic formula is this guy right here. X is equal to negative b plus or minus b squared, or plus or minus the square root of b squared minus 4ac, all over 2a. So this equation, you can only use this formula when you have this equation. Ax squared plus bx plus c equals 0. If you don't have this, so let's say this was a 3, or maybe you didn't have, I don't know, another part that you needed, you can't use this formula. So here's an example. So we see right away that we have 3x squared plus 6x plus 2 equals 0. So does this follow our equation of ax squared plus bx plus c equals 0? I would say, yes, it does, because you have your a, b, c, and it's perfect. So what you'll do is you'll take these, right? A3, so a equals 3, b equals 6, c equals 2. And you plug all those into this guy right here. When you do that, this is what you get. And then all you're doing is just solving from here. So the same thing we've been doing with kind of just simplifying and figuring it out, that's what we'll do. And when you get through all the simplification, you end up with this as your final answer. And that is equal to x. And remember, this plus minus thing here, it means plus or minus. So this actually represents two answers. It's both negative 3 plus the square root of 3 over 3 and negative 3 minus the square root of 3 over 3. So let's go ahead and work through one of these together on our own. And by on our own, I just mean without the slideshow showing us the process and the answer. So here is our equation. Here's our formula. So go ahead, if you would like to, try to solve this on your own. Go ahead and pause the video. If you don't want to do that, then we can definitely go ahead and solve it together. So first, let's go ahead and identify what are A, B, and C. So in this case, we have A is equal to 1, B is equal to 8, and C is equal to 4. And then all we have to do is plug it in. And this process can feel very tedious. It can take a minute, take a while, but it'll give you the right answer in the end. And you can't plug this into a calculator for the most part, because if you have a radical in here that's not perfect, then you'll get an irrational number. And you don't want to put irrational numbers in your answer. So let's go ahead and do this. So we have x equals negative b. So what is b? We have 8, so negative 8 plus or minus the square root of, again, we have b squared, so 8 squared minus 4 times a times c. All of that over 2a, which is 1. So that is what our problem will look like initially. And then we can go ahead and start solving. So when we solve, we keep that negative 8 the same for now, plus or minus. So here we have 64 minus 4 times 1, which is 16. All of that is going to be over 2 times 1, which is 2. So then we just have to keep simplifying. So next we have x is equal to negative 8 plus or minus the square root of 48 all over 2. But then we know we can simplify this radical. So the square root of 48 is the same as the square root of 16 times 3. This, right, the square root of 16 we know is 4. So 4 square roots of 3. So we can go ahead and plug that back in down here. X is equal to negative 8 plus or minus 4 square roots of 3 all over 2. We can now do this divided by 2, right? Because 8 is divisible by 2, and so is 4. So this is going to equal -4 plus or minus 2 square roots of 3. That is your final answer. So if you have any questions about how that was solved, go ahead and watch the video again. There's also going to be another video that we put out, which has a whole bunch of practice problems that can help you with all these topics, from order of operations to solving unknowns to factoring quadratic equations. Thank you for joining me today for IPREP Part 2. I hope that you watch more of our videos, and I hope this was very helpful. Thank you.